Good morning, sir. My name is G11. Now, I would like to start my presentation with the introduction to our topic, heart failure monitoring system. Heart failure is also known as congestive or chronic heart failure. According to the statistical analysis, roughly 26 million people worldwide are suffering from heart failure. More still, the risk of death due to heart failure has reached a maximum height of 35% in a year. Therefore, remote monitoring is a new technology invented in order to tackle with the problem of heart failure. It is undeniable that the heart failure monitoring system not only can reduce the burden of heart failure patient, but also the doctor. This is because with heart failure monitoring system, it enables doctors to review the clinical data of HF heart failure patients, such as the blood pressure level, heartbeat rate, and also pulse condition at the first moment. The reason why doctor can receive the clinical data at the first moment is because the patient status will be collected through the IoT devices such as heart rate sensor and blood pressure monitor. Then it will be transmitted to the doctor through a remote interface as well. Before the invention of heart failure monitoring system, there is actually a monitoring system called Holter monitor. The main component in Holter monitor is portable electrocardiogram, which is ECG. Obviously, it is named portable is because there is a small portable device which is connected to electrodes and stick onto a patient's chest. The disadvantages of this Holter monitor is it is run on battery. When the battery runs out, it might cause danger to the heart failure patient. Apart from that, the portable ECG will be easily disrupted by some electronic products also. In addition, since there are electrodes sticking on the chest of the patients, when the patients are sweating excessively, it might cause the loosening of the electrodes. Last but not least, the most inconvenience of using Holter monitor is it requires the patient to return the ECG to the doctor after some period, as the data of Holter monitor will not be transmitted to the doctor on the spot, but it will require to return the portable ECG to the doctor in order to review the data. Therefore, the future trend of heart monitoring system is definitely the remote monitoring system. Despite breakthroughs in heart failure management, the rate of hospitalizations remains high, and remote monitoring technology may aid in the optimization and execution of guideline-directed medical therapy to enhance the quality of life and outcomes of heart failure patients. Remote monitoring concepts entails the collection of clinical data through some IoT devices from the patients in a remote location and transfer the data to a clinician via remote interface, allowing the clinician to review the data and respond appropriately. Not only for that, but the other new trend for heart monitoring system is also known as implantable heart monitoring system. In this case, a device is implanted into the pulmonary artery and can monitor changes in blood pressure through the pulmonary artery by inserting a guide wire and sensor on the top of the wire into the pulmonary artery. Therefore, it is undeniable that these new evolutions of heart failure monitoring system can make the heart failure monitoring system become a focal point to everyone in the future. Heart failure is still one of the most common and serious medical conditions in the world, and patients with heart failure are at risk of recurrent hospitalizations. However, there is an increasing trend of reducing length of hospital stay, which aims to improve clinical outcomes by maximizing the utilization of hospital resources and reducing the cost of patient care. The COVID-19 pandemic has increased the necessity for a new method of healthcare delivery, the virtual visit or virtual patient care. Remote monitoring technology is not only able to provide early warning signs of heart failure decompensation, but also allows therapy to be tweaked to avoid excessive hospitalizations. Furthermore, delay in access time of clinic visits are common nowadays. Besides bringing prisoners to patients, it is also a burden to those who are sick or having medical emergencies. Due to that, healthcare providers need a new platform or tool to increase the clinical outcomes of the heart failure monitoring services. In the traditional monitoring process, patients are required to go for the clinic visits frequently for continuous monitoring. However, healthcare access in rural communities becomes an issue due to the long travel distances to the hospital. Hence, Patients living in rural areas are requesting for a more convenient healthcare system for them to continue receiving care without going for the physical clinic visits. The aim of this project is to develop a cloud-based solution to resolve limited clinic capacity and long patient travel distances problem. The main objective of this project is to perform remote patient monitoring through software application to improve care transitions. In this project, the developers make use of several services and tools provided by Amazon Web Services (AWS) to complete the cloud-based solution development. The system will aid in the optimization and execution of guideline-directed medical therapy to enhance the quality of clinical outcomes of heart failure patients. Furthermore, sensors such as heart rate sensor, pulse oximeter, and blood pressure monitor will be implemented to collect real-time vital sign data from the patients. All the collected data are to be uploaded to the cloud platform to perform real-time analytics, and alerts will be sent to the concerned department for further actions to be taken. That's all from my part. Now I will pass the presentation to the next presenter, Chu Ying.
Good morning, Dr. Cheng. My name is Chu Ying. Now I would like to talk about the concept of our system. The concept of our system is to monitor the heart disease patient frequently. So the Internet of Things, which is the IoT, will be the main component in this system, which is the various types of sensor devices that can monitor the heart condition. For example, pulse rate sensors, the pulse oximeter, the blood pressure monitor, and so on. While the mobile application will be the medium used to transfer the data and store it inside the database. The web application is used by the doctor to monitor the patient in real time so that the doctor can always get the latest condition of the patient. Now, I would like to talk about the architecture diagram of our system. First of all, the Emergent Committee service is used for the authentication and authorization process. It is a managed service that adds secure authentication and authorization to the applications, which can be scaled to support millions of users for both mobile and web applications. Emergent Committee service can create the user pool based on the system requirements by adding the extra security layer to the system if necessary. The sign-up experience is also able to be configured depending on the business rule. Next, the AWS IoT Core is a service that connects multiple things to the Internet easily. In the heart failure monitoring system, the publish-subscribe model is used at the mobile application side. Multiple physical devices are allowed to connect to the AWS IoT Core in order to communicate with each other easily. The sensor devices that are used to monitor the patient's heart condition will be published a message containing the sensor reading, for example, the beats per minute to the AWS IoT topic through the MQTT protocol. The mobile application that subscribes to the topic that the sensor is published to, then it will receive the readings of the sensors. In order to connect the things, can be sensors, mobile devices, or any intelligent devices to the AWS IoT. It requires the certificate and the private keys. During configuration, all this information should be kept secret in order to enhance the security of the system. After subscribing to a MQTT topic, now we should store the readings received from the sensors to the database inside the AWS Cloud Platform. Before storing the data, now we need to pass the API gateway in order to access the services inside AWS. Else, the request will be blocked due to the security rules that are being configured. In this system, Amazon API Gateway is used to manage all the API that can access the functionality in the application. The Amazon Gateway does provide different API types such as the HTTP, WebSocket, and the REST API. But in our case, we will use the REST API to perform the operation since it provides complete control over the request and response along with the API management capabilities. The security layer is also added to the APIs, which require the user to log in before allowing them to perform any operation to the database and other services. Once the authentication process is passed, the user will be authorized to access the service inside the AWS cloud. The request containing the authorization header that's sent from the mobile application will be sent out to the AWS Lambda. AWS Lambda is a service that allows us to run the code without thinking about the servers, which can make the implementation to be much easier. In the hard failure monitoring system, the AWS Lambda acts as the backend logic, which is used to process the request before proceeding to other actions, such as the reading or write the database and execute the notification service. In the execution of AWS Lambda, it will compute to decide which operation to be carried out based on the request that is being received, and make the corresponding response to that. In the architecture diagram, there are two Lambda functions. One is to access the database, and another one is execute the notification service. Besides that, the database used in this system is Amazon DynamoDB service. Amazon DynamoDB is a fully managed key value and documented database that can deliver single-digit million-second performance at any scale. Amazon DynamoDB is a fast and flexible NoSQL database service for any scale, so that the attribute inside the table can vary, unlike the SQL database, where the attribute for each record must be fixed at the moment the database is designed. In our case, Amazon DynamoDB will mainly be used to store the patient data, which include lots of sensor reading from different types of sensor devices. The reading should be stored for a certain time or as the analysis and comparison during the monitoring process. Moreover, the Amazon Simple Notification service is being triggered by the AWS Lambda function. The analysis result that's sent to the AWS Lambda is computed at the mobile application side. Once the mobile application has received the subscribe message, it will compute whether the readings are considered normal or not. For example, at a resting heart step, a normal BPM range is between 60 to 100 per minute. If the reading is up or range consecutively, then it will trigger the Lambda function to execute the Amazon SNS service. It is used here for sending an email notification to the daughter email if an abnormal situation is detected during the monitoring process. It can prevent the daughter from missing out on critical sessions when they are busy. It is similar to how the mobile application subscribes to the topic that is published by the sensor through the MQTT protocol. In our situation, AWS Lambda is used to publish the notification containing the message to the topic that's subscribed by the daughter email. Then an email notification will be sent to daughter email every time when the condition is met. For example, when 10 consecutive abnormal readings are detected. Last but not least, for web application, the daughter are allowed to access the Amazon API gateway to retrieve the patient data after login. The purpose of the web application is to assist the daughter to monitor the patient under monitoring remotely and anytime as long as the monitoring process is enabled. When the configuration AWS Web Services, there are lots of security rules that can be added in order to having a secure environment. And a secure environment will guarantee a good user experience and ensure the data integrity, which are more concerned by the user when using the system. That's all for me. Now I would like to pass to next presenter, Teo Kai-jun.
Last but not least, I would like to briefly explain about the study of different IoT platforms. The IoT platforms that are being chosen to study in this project is AWS IoT, Azure IoT, and also Google IoT. AWS IoT is a web-based platform that offers scalable and cost-effective cloud computing services. Azure IoT is a set of cloud services hosted by Microsoft for connecting, monitoring, and controlling billions of IoT devices, while Google IoT is a Google provider suite of cloud computing services that run on the same platform that Google uses internally for its end-user products such as YouTube and Google Search. First of all, let's talk about the communication protocol. AWS is using HTTP, MQTT, and also WebSockets, while for Google Cloud, it is using HTTP and MQTT. For Microsoft Azure, it is using HTTP, MQTT, and also AMQP over WebSockets. For the main functions, AWS IoT Core performs the function of connectivity, authentication, rules engine, and also development environment. While for Google Cloud IoT Core, it performs the function of connectivity and device management, while Azure IoT Hub works as connectivity, authentication, device monitoring, device management, and IoT Edge. That's all presentation from the report session. Thank you.
Hi all, we are from Group 11 and our topic is heart failure monitoring system, and this is the configuration manual, and which will be presented by me, Tai Yuan, and also our leader, Cheng Li. Now, I will show you step by step how our system can be configured using our manual. First step, sign to the AWS console. This is the AWS management console. Let's click the sign into the console. And the page will be shown like this. You can sign in as a IAM user or also a root user. In this case, in this demo, I will show you how to sign as a IAM user. You key in your account ID, your username, and your password, then click sign in. Wait for a while, and the console first page will be shown like this. Okay, now we proceed with the Amazon Connector service, and we follow the manual step by step. In the AWS console, search for Amazon Connector service. In Connector, and click this. We enter the first page of Connector service. And follow the manual. In the Amazon Connector service, click Create User Pool. Here, click it. And in step 1, tick the email for sign-in options and click Next. Here, email, tick, and Next. In step 2, for the multi-factor authentication part, which is here, we choose No MFA and click Next. In step 3, nothing should be changed. Use back the default configuration and click Next to proceed. In step 4, choose Send email with Cognito, this one, and click Next. Step 5, give a name to the user pool. In this case, type ECS demo ancient. And tick the box, use the Cognito hosted UI. Then choose use the Cognito domain as domain type. Use a Cognito domain. Enter a domain prefix. So we follow this. ECS demo available. Select confidential client for app type. Confidential. Enter your app client name. Let's say heart failure monitoring system. And the callback URL to be redirected after login. In this case, we just randomly pick a website. Let's say google.com. Scroll down and explain advanced app client settings. Here, expand it. And select allow user password auth for authentication flow. Here, allow user password. Okay, take it only, so we untick all the other. Allow user password for add implicit run here. And select only OpenID and email for OpenID connect scopes. OpenID and email. And click next. The step 6, review again the configuration. If done, click create user pool. We review all user pool set option, email, and no MFA, email only, email, ECS demarcation, use the cognitoster UI, domain name, add client name, callback URL, email. Yeah, that's it. Create it. Yeah, that's all. You can see we have created a DCS demarcation user pool. Yes, it's been successfully created now. Now let's proceed to the Amazon IoT core. First, find the IoT core from the search bar as usual. IoT core is enter it. Then the next step, you should be able to see the main page like this. And we go to manage things here. And we need to create a new thing. Create. And we want to create only a single thing. So create a single thing. Give your thing a name. In this case, we give it name DCS demo power sensor. And all this keep as default and we click next. Then at here, you are advised to choose the auto-generated certificate. So you click the create certificate here. Then the certificate will be generated and you need to download all these certificate, public key and private key to connect to your IoT devices. And also this one, you need a root CA. Activate it. Okay, so click done first. After that, you need to attach a policy for your new thing. Go to the secure and policies. Create a new policy. And then make DCS demo power sensor policy. And for the action, choose allow effect and the action IoT or the resource ARN or then create a new policy. After that, we have created a certificate just now, which start as 3225E, this one. Create that, deploy it in, correct. Then we attach a policy that we created just now to it. Attach a policy, then choose DCS demo power sensor policy and attach. Okay, so repeat the same steps to create a new thing for mobile application, and the IoT things table should contain both of the things created. So I'm not going to show again the same step, but you need to create a DCS demo mobile thing, just same step as the demo power sensor. And that's all for the IoT core. Now let's proceed to the Amazon DynamoDB. And we'll follow the manual. First, search DynamoDB from the search bar. Type in Dynamo. First one, and we enter the DynamoDB page. First of all, click the Create Table button to create a new table. Here, Create Table, and we give our table a name. We follow the manual. For example, I click in DCS demo patient for the table name. DCS demo patient. And for the partition key, I will give it a patient ID in this demo. Then keep all the settings as default. Scroll down to the bottom of the page and click Create Table button to create a new table. All this, keep it as default and create a table. Yeah, a new table is creating named ECS demo patient. And after a few minutes, the table will be activated and the status will be changed to active. Yeah, see the status is active now. Click it to see the table. Now the table is of course empty because it just created just now. Okay, now we'll proceed with the AWS Lambda part 1. In the console, search for Lambda service. Lambda, then choose the first one up here, Lambda. Then step 2, at the left navigation panel, select functions and click create function. Function is here, and you've got the create function, click it. Then enter the function name. Make sure Node.js language is selected for runtime. Function name. Let's give it a DCS demo DynamoDB. DCS demo DynamoDB. And Node.js is selected. Architecture, choose x86 64-bit. Then after creating function, okay, so we should create a function first. It takes some time to create a function. Okay, the function is successfully created. Now we proceed to create a function. At the code source section, copy and paste the following code into the index.js file. Remember to deploy. Okay. Code source is at here. You copy the code, copy it, and select all, paste it here. Okay. Remember to deploy the function. Okay. Successfully. Okay, so the code has been deployed successfully. Now, that's all for the Lambda part 1. Now we proceed with the Amazon API Gateway part 1. In the console, search for Amazon API Gateway. Search for API Gateway. Click the first one up here, API Gateway. In the Gateway service, click the Create API. Okay, let's see. Okay, here, Create API. Follow the menu. Find the REST API and click Build. REST API here, click the Build. Give a name to API and click Create API. API name, in this case, let's say DCS demo mobile web API. API DCS demo mobile web API. And click Create API. Name is correct. Create it. Next step is after creating API, the following interface will be shown. All the APIs will be managed in the resources. Here. And select actions, create resource. Action, create resource. Enter the resource name. Resource name is a DynamoDB APIs. DynamoDB APIs. And for the resource path, there's a demo DynamoDB. DynamoDB. And take the enable API gateway CRS. Here. And click create resource. The next step is select the resource created just now. Okay. And create this one. Select actions, create method. Actions, create method. Then we select the post method. Click confirm to create the post method. Post. Post, confirm. Okay, the post method is created now. Like show the Lambda region, same as the region you implement all the services for this project. US is 1. US is 1 is correct. And type the Lambda function name created previously, except previously we create the Lambda function called DCS demo DynamoDB. DCS demo DynamoDB. And click save. Okay. Okay. Yeah. Repeat the same steps to create APIs for any get and put methods under the same resource. Option method can be deleted since it's not required for now. And repeat the same steps again to create new resource for Amazon SNS. Create post method under the SNS resource. And I'm not going to show you all this because the step is just same. You can create that all this any you get and also another resource yourself. Yeah, and that's all for the Amazon API Gateway section, part 1. Now let's proceed with the API Gateway part 2. Select authorizers from the left navigation pane. Here, find the authorizer. Then we click the create new authorizer button. We fill the details such as name, patient login, or patient login. The type, choose connector. And the user pool, choose the DCS demo patient. Token, we put authorization. Follow the manual and then click create. Then we repeat the same steps to create another authorizer for doctor. Authorizer. Then we put doctor login. And cognitor type. Choose DCS demo doctor for user pool. And the token is still the authorization. Then we create. Okay, there's 2 authorizers here. One is patient login for patient and another is doctor login for doctor. We go back to the resource. Select the any method under DynamoDB API. DynamoDB API is this, and any method under the DynamoDB. Then we click the method request. We change the authorization from none to authorizer for doctor, which is doctor login. See, previously it's none. Then we set an authorizer for it, doctor login. Add 3 query string to URL query string parameters. URL query string parameter. Okay. Add query string. Operation. Payload. And last one is table name. Then repeat the same for the remaining methods under DynamoDB and also SNS API resources. Get method under DynamoDB resources with doctor login, post and put with patient login, and post under SNS with patient login authorizer. Yeah, that's all for the API Gateway Part 2. Now let's proceed to the API Gateway Part 3. First, we select any method from the DynamoDB resources. Here, any. Then we click the integration request, this one. Then expand mapping template section. Here, the bottom one. Then add mapping template. Add mapping template. Fill in application / JSON as the content type. Application / JSON. Tick. Yes, secure this integration. Then we copy paste the following script to the template. Click save. Save. Then repeat the same steps for get method under DynamoDB with the following script. Go back, get method, integration request, mapping template, application / JSON, tick. Yes, get this integration. And save it. Yeah, that's all for the API Gateway Part 3. Now let's proceed with the API Gateway Part 4. Select actions, deploy API. This one, we select actions and deploy the API. Okay, select new stage for deployment stage, new stage, and give a name to the stage. Let's say demo, and deploy it. Yeah, and the API gateway has successfully been deployed. Demo stage editor will show here. Yeah, that's all for the API gateway part 1 to part 4.
Hi, good day, Dr. Michael and also Dr. Ashwani. My name is Zheng Jie. So now I will continue on set out the SNS. First is we need to go to the service first. Okay, so just search for SNS. Okay, so the next step is okay. Now we need to create a topic here. So just from the left navigation here, okay, just click on topics and then create topic. So based on the menu here, okay, so just select the standard. You also name it as the DCS demo alert. So standard DCS demo alert, and then just scroll down to the bottom page and click on create topic. So just leave the other configuration, okay, by default, using the default configuration. So create the topic. So here, this is the topic we create. Okay, so if we so we see the table here, okay. So now here there's a new topic that we create just now. Just now, we just select it. Okay, then under the subscription tab here, then click on the create subscription. Okay, so this is the ARN for this topic. So and then for the protocol, okay, we choose email, and then the endpoint. The endpoint here is the email that we subscribe to this topic. So I will just use my email. So the endpoint, okay, I will just use the Utah email. Okay, and then just create the subscription. So now it's showing that the status is pending confirmation. Okay, so we need to check the email. Okay, so you will receive a confirmation email from AWS. So just click confirm subscription link. Okay, so now let's see the email. Okay, so I'm at that email here. Okay, so this is the email I received. Okay, and then confirm the subscription. So yes, click on this confirm subscription. Then it will bring us to this interface. Okay, so subscription confirm. Okay, and also we can unsubscribe it anytime. Okay, so we just close this window. Okay, and then refresh your AWS console. You can see your SNS topic status has been changed to confirm now. Okay, subscription. Okay, alright, we just refresh. Okay, now the status become confirmed. Okay, so that's all for the SNS notification and also the subscription to this topic. Now we will continue on the AWS Lambda part 2. So if you still remember, the part 1 is to create the Lambda function for the DynamoDB. So now the part 2, okay, we will create a function for SNS service. Okay, so we just search for Lambda. Okay, so this is the Lambda console. So this is the DynamoDB we create in Lambda part 1. So now we just repeat the same step in AWS Lambda part 1 to create a new Lambda function for Amazon's SNS. Okay, so now we just create a function auto from scratch. Function name. Okay, so for the function name, okay, we just put DCS demo SNS. Okay, and the runtime, okay, just put just select the Node.js and the architecture. Okay, and then okay, just keep the default configuration. Okay, so create a new role with basic Lambda permission. So once we create the Lambda function, right, okay, it will create a new role. So just create a function. Okay, so waiting for create a function. We see the next step. Okay, so go back to SNS Lambda function. Okay, this is the function that we just created now. Then click on the add destination. Okay, so okay, this is the Lambda function we create. Oh, sorry, I just missed out one step. Okay, in this step, okay, copy and paste the following code to the index.js file for SNS Lambda function. Okay, so the index.js file will be this one. Okay, this one. So this is the default coding. Okay, once we create. So now just copy this one, then paste here. Okay, so this is the Unicode, so we need to change the single quote here. Also, and then we need to change the to change this one. Okay, your SNS topic ARN. So where we can get the SNS topic ARN. Okay, from the SNS service. Okay, so never mind. We just save it first. Okay, then we go back to the SNS. Then go to the topics. Then select the topics that we create. So this the DCS demo alert. So here will be the ARN. Okay, so just copy it. Then go back to the Lambda function. Okay, so DCS demo SNS. Then under the code here. Okay, so just change this. Replace this. Okay, to the ARN we copied just now. Okay, so now that's all for the coding.
Now we try to deploy it. Okay, so this step is done. Now we go to the SNS function again. Okay, so just click on the add destination. So just add destination, and also synchronous invocation, permission on success. Okay, settings here, and SNS topic. Okay, and the destination is the SNS topic that we create just now. So just select the DCS, then DCS demo alert, and then click save. Yes, now we go to the next step first. Okay, so at the end, the table should contain both of the lambda functions created previously. Okay, so this is the function. Okay, so now we go back to the SNS again. Okay, as you can see the image here. Okay, the image here is this one. Okay, before we add the destination, right? Okay, did you notice there's a API gateway here? Okay, the trigger function. So, but here is missing. But never mind. We just go to the API gateway. So the API gateway, okay, this is the function that we use for this demonstration. Okay, and then for the DCS demo SNS, it is post. So this one, the lambda function. Okay, and then the region is correct. There are two resources here. Okay, so the first DCS demo SNS, this one is for the SNS lambda function, and then this one is for the DynamoDB. Okay, so previously when my teammates create this one, okay, there's no lambda function for SNS yet, so now I just change this one back to SNS, okay, instead of DynamoDB. Okay, so confirm it again. Okay, now we go back to the lambda function, then the DCS demo SNS. So now we can see there's the API gateway here already. Okay, yes. So that's all for the SNS setup. So now I will continue on AWS IAM. If you still remember, okay, in Lambda part 2, okay, it's showing that there's no permission to send result to the destination SNS for the Lambda function. Okay, so we just go to the IAM console first. Okay, search for IAM. Okay, so select the rows from the left navigation pane. By default, okay, since just now we have take an option, okay, saying that the AWS function once is created, right? Okay, so it will create a new row, okay, for the lambda function. So the name of the row, okay, will be the same as the function name. So now we just look for that. So DCS demo SNS and also the DCS DynamoDB. This is the two lambda function we created previously. Okay, so for the next step, select the SNS lambda row first. So this will be the interface, okay, and then click add permission to attach the policy, okay. So this is the default policy added, okay, so just ignore it. So add permission, attach policies. So search for SNS to filter the policy for SNS function service. So we just click on this one, Amazon SNS full access, okay, to give the full access to SNS service, and then attach policy. Okay, so same things here, and then repeat the same way for the DynamoDB Lambda row. Okay, so we just go back to the rows here, then select the DCS demo DynamoDB row, then add permission, attach policies. Okay, so this time, okay, we are going to add Amazon DynamoDB full access. So just search for Amazon DynamoDB. Okay, so there is a full access, then attach the policies. So now we already done added. Okay, so that's all for the IAM row. Okay, now we can access to the DynamoDB and also the SNS service, okay, through the Lambda function we created. So now we have done all the setup for the AWS services. So now we will start on the demonstration for this system. So to get the same project, okay, you can download the project from this GitHub link. Okay, so after you get the project, okay, so just open up this project. So inside this project, okay, you can see. Okay, so now the things we want to add the AWS LT SDK first. So the SDK, okay, it allows us to choose from several programming language, okay, which is the Python, C++, JavaScript, and also Java. But in this demonstration, we will just use the JavaScript, which requires the Node.js. So make sure you have installed this Node.js in your machine. So this is our project. So inside here, okay, you can see there's the cert folder, and then inside the cert folder there's a mobile and also the sensor. So here will contain the certificate of the IoT things we create in AWS previously. So just ignore some of this because all those are used for testing. So the one will be used for this demonstration is this one, 3541, and also the 3221. Okay, so if you still remember, okay, last time you can download this once you create the IoT things. So in this demonstration, we will just use the certificate, the private key, and also the CA1. Okay. So now I will explain some of the configuration. Okay, so in this project, okay, there are two things. Okay, you can one is the IoT.js used to mock the pulse sensor in real world, and one is the mobile.js for mobile application. So you need to fill in the key path, the cert path, the CA path, and also the endpoint. So the client ID is basically a unique key for this LT. So key path is where you store this private key file. So in my case, okay, it will be cert mobile, and then to this file. Okay, same for the cert path and also the CA path, and also same for the IoT.js sensor. Okay, and then for the host here, okay, is the endpoint of the AWS IoT core. You can go to the AWS IoT core service and go to the settings, then you will see the endpoint. So for this slide, okay, you can also add the package, the SDK, okay, by using the command yarn add or npm install. But in this project, okay, I already added. So the first thing when you get this project, okay, you just directly run the yarn command or just the npm install. Then it will directly install all the dependency used in this project. Okay, so for the connection part, okay, it will be this one, okay. The sensor, okay, once it's connect to the IoT things, so while true, it will just keep looping. Then the sensor will publish to this topic. Okay, so this will be the data. So this UID is unique. So every sensor will have their own unique ID. So for this demonstration, okay, you can just use the online generator, okay, just to generate a UID version 4. So for the mobile app, okay, you need to change the input here, okay, based on this UID. So this input here, okay, it indicates that, okay, which host sensor you need to you want to subscribe to, okay. And then this will be the user email, and then the UID here, okay, this will be the patient ID, okay. This one later we will need to change, okay, after we log in the user account. So once it receives the message, okay, so it will just change the message to JSON format, okay, something like this. And also there's one more thing, okay, for the SNS service, it will notify the doctor, okay, if the readings is lower than 60 or higher than 100. So for this demonstration, okay, we just set for one consecutive BPM readings, but in real world, okay, we will set to 10. So now it's just for demonstration purpose. So now we go to the postman. Now we need to create a new user account. So go to the authorization header or off 2.0, okay, this is all the settings. Token name, the grant type, the callback, okay, this one just simply put because it's not that important for this demonstration. And then this auth URL and also the client ID can be get and also scope can also get from the Cognito service. So now we try to get a token. So sign in with different user, okay, and then sign up. So sign up with this email first, and then password. So we will need to get the verification code to identify to verify our email. So just copy it, then paste. So proceed. Okay, so this is the token that we get. Then we copy this ID token, not the access token, this ID token. We just copy it and then paste at here and then save. So remember to change inside the mobile application here as well, because we assume that, okay, this patient is logged in for is current login for this application, and save. So we do the same for the doctor as well. Okay, so the setup is also the same. Create a new account for the doctor also. For the doctor, I will use the Utah email. Then the password. Okay, so same. We go to the verification, we need to get the verification code. sorry, the code is wrong. Okay, sign up. So now we will get the code. Okay, so this code. And then verify the email. Okay, same things. Copy this token. In order to access the API later on. So copy and paste. Remember to save. So now, before we test on the application, now we need to create a new patient record inside the DemoDB. Okay, so you can see inside this user pool for the patient, right? We have sign up for the patient, same for the doctor. Okay, but inside the DynamoDB, okay, there is still no record. Okay, you can see there is no record here. So now we need to create new patient. So this is the body set in this request operation create table name and also the item. Okay, the patient ID. This patient ID we need to get from the cognito. Okay, this ID, just copy it. Okay, paste it. Okay, so the email is the same. And then the post record, okay, is still the empty array. So this link, this is the API, okay, we already deployed in the API gateway service, so you can just find from there. Then now we just send the request. Okay, so now successfully send the request. So we go to the DynamoDB. So you can see inside this table, okay, there is a record already. So now we go to the application. Okay, so for the application, right, for the user the ID, remember to change also. Change to the patient ID of this user. Okay, and then remember to save. So now we need to run the application. So for nodemobile.js, okay. Now we have connect and subscribe. Then for the port sensor is connect also, and also a message is sent. So a second message is sent. Now we stop the sensor. So we subscribe to the topic and receive these two readings, 95 and 82. So we go to the patient table. Now you can see inside this DynamoDB, okay, we have two records already. One is 95 and 82, which is the same as here. So now the doctor is trying to get the patient information using the get all patients API. So same here, okay, this link can get from the API gateway. So there is no body pass, and also the request is the option method option, and then send. So you can see it returns this patient ID with this email, okay, it's 95 and 82, okay, that's correct. So now we try to go for this get patient, get only a single patient. So for the parameters, okay, we change to this value so that we can get a specific patient. So yes, it's success. So now the one last thing is the SMS notification. So now we just comment out this and then change to this. Okay. So it will just randomly generate 101 until 150. So once there is one record is one readings, okay, is abnormal, so it will just directly send notify the doctor. Okay. So now same things, subscribe first, and then we run the pause sensor. Okay, so we stop it. So now you can see we have two record 109 and 147. Then we go to the email. Okay, so in the previous setup, okay, the subscription we use, the email subscription we use is the Utah email also. So you can see this. Yes. So we received two notifications. Okay, so that's all for the demonstration. Thank you.